This video will show the RPU running a diesel engine. The control model was originally developed by a student in a 6-week LHPU course on diesel engine controls, and then converted to run on the LHP RPU using the RPU block set. This work was done as a proof of concept with an early prototype version of the LHP Simulink block set and calibration tool. What you will see is the first test using the RPU in an actual control application. At this point, the team had already connected the RPU in parallel with the original ECU and verified that the output signals agreed and are in sync. They were about ready to run the RPU in full authority control when I walked in and asked them to roll cameras and walk me through the demo as if I were a new user. I hope you find it interesting. So first you're going to open the model, right?
Right.
Show me what you've done.
It's generating the files, when it's the initialization stage, so it's generating the CAN database file and checking the signature. If it's already generated, then it skips. Okay, so
this is
the target definition folder, yeah. Yeah, here it is.
So this is the bit file?
This is the bit file, yeah. And this is the IP
address of the target.
Right.
Yeah. Okay.
This is the bit file I'm getting. This was the folder from where I opened the Simulink model.
So
you see those extra files. These are generated files, like in the initialization stage.
Oh, the database.
Yeah, this is where it created the database, and these are the register list.
Yeah, database. Yeah.
Okay. And then, so I'll browse to this folder. It's the same folder, and this is the bit file that I want to select. And I just click OK.
That was already set.
It was already set, but I just
Yeah.
Yep.
where I want
Showing how it works.
Right. And this is the CAN database XML file,
Okay.
which was on the same folder. I already saved it in the same folder. So, and then I click OK. Yeah. So this file is already generated, but it checks every time. Make sure the XML file is, if it is changed, then it will generate the file again.
Okay.
And then these are some of the blocks to blink the LED on the RPU.
Right.
And these are the hardware interrupt. So these hardware interrupts will trigger these blocks,
Okay.
and these interrupts are associated with the engine cylinder top dead center.
Right.
So as the engine speed up, those LEDs will blink at a faster rate, and as the engine slow down, they will blink at a slower rate.
Okay.
So it is event based. These blocks are acting on a event based trigger.
Okay.
And then this is the foreground where
That's
we
your
have
actual
our
controller.
That's our actual controller, yeah.
Okay.
So this is the
This
Simulink sensor block, yeah.
It's a model.
Yeah. So it has a lot of stuff. Looks like this is the AD combo block where it gets the signal from the AD combo module on our hardware.
So that's all of your AD inputs.
AD inputs,
including APP, which is the one you
right.
chose.
From the calibration tool, we can change the channel, whatever channel we want.
Okay.
So right now it is hardware to channel number 4. So in our model, I put it as number 4.
Okay.
Okay.
So finally we get the APP percentage. This is the key switch signal. If the key is turned on, then the signal will come down to here,
Okay.
from here. And then this is the EPT control, or the engine position sensor. So there are lots of stuff going on here.
To calculate engine
Yeah, to
speed.
calculate engine speed, yeah. And it takes some time to load our RPU blocks, FPGA read and write blocks. These are the blocks. We can find it in the user manual that we will provide with our product.
Let's just go ahead and build it and
Yeah, I just
deploy
went
it.
to- So yeah, our Simulink model is very rich with our blocks because it's communicating lots of data with the.
Okay.
Yeah, and this is, you see, these are all the FPGA read and write blocks. This is kind of special kind of block because it's an enumeration data type, so it has the list of all those digits, or what they mean, the strings. Okay, and then this is the governor block. This is our
Control
the engine
strategy.
controller. Yeah, this is the engine states, like it decides if in the stall state, crank state, run state. This is the block which calculates the fuel per cylinder, calculate FPC signal, send it out from this block. Yeah, these are just the, I don't know.
Okay.
Different control
Okay,
strategy.
and then this is the signals coming out to the actuators,
Okay.
and then signals going out to the CAN message block, these are the CAN messages that we're sending out to the fuel pump.
Correct. VP44.
VP44, right? And here, as I showed here before, like this is the CAN database which is actually used for generating those CAN message
Okay.
encoders and decoders for those CAN message blocks. Okay, so I'll go ahead and build.
All right.
Yeah, so I hit build. It is building. If I could show you the diagnostic viewer.
Does it take a while?
Yeah, it takes maybe, because it's a big Simulink module, 1 or 2 minutes.
Okay.
But the cool thing about this is that once it builds, it will automatically deploy the compiled file. The user will not have to open the KL tool to manually copy or deploy that compilation file over to the hardware.
So you mean the model, the compilation will be automatically transferred to the hardware?
Yeah. So that's
Okay.
the
So
thing.
you can build straight from Simulink and deploy
I
it.
can build straight from Simulink and deploy it to the hardware.
Awesome.
Yeah. So it has, when this command prompt window prompts up, that means it is already deployed to the target. Oh, I promised that I will open the diagnostic viewer. Here it is. So it generates lots of files. And then finally, after it generates all those files, this is the file that it generates, and then send it over to the target. So the file is now already running.
So it's already running on the
It's
target.
already running. So
Okay.
I can actually go ahead and start the engine, or should I start the CAL tool first?
Let's
and-
open up the CAL tool so we can observe what's going on.
Okay. So our CAL tool is just a handy CAL tool that we built for our purpose. The user can use any kind of CAL tool they want. So right now I'm gonna open the A12 file. Is a industry standard A12 file. So this is the A12 file that our compiler generated. It's
LHPU, EOP.
yeah. So I'm gonna go ahead and start building. Start
So
our
we
CAL
will
tool.
refresh this.
Yeah.
one?
Right.
Okay.
So yeah, it is.
Okay, so
the
now
CAL
we're
tool
running.
is running. Yeah.
So the red line is
The white. This. Yeah. You can
You're
explain.
plotting engine speed on the white trace,
Yep.
APP on the red
On the
trace,
red
and
trace.
FPC on the green trace.
Right.
And down here is your calibration.
Yeah. You can.
These are your things you can calibrate.
Yeah. You can actually clean
Okay.
the table and make the table again if
Okay.
you want. Should I do that?
So what you are putting on the table now?
Okay.
Okay.
Sure, we can start from scratch.
Right. Start from scratch.
Okay.
So first I'm gonna put the idle speed.
Idle speed.
Okay, let's go ahead in the Simulink model and find where is the idle speed. The idle speed was in this one, governor, calculate FPC, run, cal_idle RPM. And then, so I need to go to, I think it
that's
was
same-
already,
the
yeah, it was
tree
the same level. That's the cool
file.
thing about our cal tool is that we can, I mean most of the cal tool they have all those calibration parameters as a list, but we can actually organize them layer by layer as they were organized in the Simulink model. So this is the calculate FPC, this is the run block, and inside the run block there's the idle RPM. So I just drag and drop it on the
Drag
table.
and drop.
Right. And then
Okay.
it also had that maximum RPM value that's gonna be our max maximum RPM for the engine that we have set for.
Okay.
Okay. I think we
Ready
can
to
go
start
ahead.
the
and-
engine?
Yeah. So now it's set to 700.
Okay.
So,
Yeah, let's go ahead and raise that up to 800.
800.
I think it'll be a little more stable.
Yeah. So this thing went up to 800. So I
So
can.
now we can try
Yeah.
max RPM. Let's increase the APP.
So now the RPM is now settled at 1500. So I can change
Let's
that
change that.
to
1600, sure.
16. So now it's went up to 15 to 1600.
Yes.
And then I will take it to 1700.
Okay.
Yeah.
There you go. Now back down to 1500.
All the way down to 1500.
Sure.
So yeah, again,
Excellent.
again settled down to 800.
It's stabilizing down to 800.
Yeah. Yep.
All right.
And I can also turn off some of the plot if we
Right.
don't want to see.
Can you show me how you would plot something
Oh yeah, sure.
if we want to add something?
Right.
I don't know what you might want to add.
Okay, I am resetting all the channels again.
Okay, so now you've got nothing.
Now I have nothing. If I start to measure, it will not plot anything because on the channels there's nothing. It just froze.
Okay.
Okay, so if I click on this button measurement, this table will pop up and it's the same table like this one. It says here the measurement parameters and this is the calibration parameters. So on the measurement parameters tree, I can browse to the engine speed first.
Okay. Is that under sensors?
It was, oh yeah, it was
Okay.
engine speed. It says here
Alright.
engine speed, so I can select it here, and then
That puts it on channel 1, or you can just drag and drop, right?
right.
APP on channel 2.
So
There
this
you
is the APP, and then the final one was the what
go.
was it?
FPC is under CAN.
CAN message.
Part of the CAN message.
Yeah, we're sending the FPC signal to the fuel pump.
Right.
Okay, so this is the FPC.
There you go. Now you just hit measure and you're running.
Let's just clear this chart. So it'll be a new.
Start over.
Yeah.
Yep.
So press the pedal. Do some more calibrations. So it was now 800, take down to 700.
Not 7,000.
Not 7,000, 700. Take it up to 900 again. Or 800. Or 900, yeah, sure.
Sure.
Boom, it went up to 900. From 700 to 900.
There you go.
Yeah, then go to the next level if you will. And take it all the way up to 1700. Our controller is good.
It is good. Oh, sorry. I
Oh
dropped,
no, that's fine.
I dropped it. Dropped it.
Yeah. Okay, so
Very
and
good.
I can also clear the table.
Start over.
So yeah.
Alright.
So that was all over.
Excellent.
Shut it
Shut it down. Thanks. You've just seen how the LHP RPU can accelerate the development and testing of model-based controls in Simulink by deploying on National Instruments hardware using the LHP Developer Suite. For more information about the RPU or LHP consulting services, please contact LHP by email through platform@lhpsoftware.com or contact your local National Instruments sales rep and ask about the LHP Rapid Controls prototyping solution and how it can work for your application.